It's called the general gas equation. The general gas equation can be delivered any two of the three gas laws can be used to derive it. Now consider we have a gas of a fixed mass at a temperature 1, occupying a volume that is V1. If the pressure of the gas is changed from P1 to P2 at constant temperature, when we are talking about temperature is given constant, then we have to determine the volume. Now, if you look at here, what means from Boyle's law? This is how we do it. Boyle's law. Now, P1 V1 is equal now to P2 V naught. This means this is the new volume. And this comes from this statement. We say if the pressure of the gas is changed from P1 to P2 at constant temperature, then also the volume is changed to this one. So this is the new volume. This is the volume before. Once the pressure is changed from P1 to P2, now we determine also the new volume. Here it is. But consider also the pressure P2 of the gas is heated from temperature, heated from temperature this one to this one, while the pressure is constant. If now you keep the pressure constant, this one, the second pressure that you have obtained, you keep it constant. According to Charles' law, you will be having, this is the first volume, this is the new volume to this Boyle's law. But this is the volume, the first volume to this law. Now this volume will be changed to a new volume. Therefore, from these two equations, one is P1 V1 is equal now to P2 V this one. This is the first one, and this is the second. Now let us make this one. Let us make this one here as the subject. That is to say, if now in cross multiplication, you find V this one T2 is equal now to T1 V2, making the subject over T2 over T2. Now we say a new volume of this one is equal now to T1 V1 over T2. Therefore, we substitute this one to here. Means now you have P1 V1 is equal now to P2. Then in bracket you have T1 V1 over T2. This one. Therefore, this will be equal now to P1 V1 is equal now to P2 T1 V1 over T2. Now we divide by T1, we divide by T1. Therefore, this cancels out. Therefore, we remain with P1 V1 over T1 is equal now to P2 V2 over T2. This is what we call it general gas equation. General gas equation. This means what? If now you find the question involves all the three factors that we have discussed. Involves the pressure, that is V, also involves the volume, that is V, and also involves the temperature, that is T. Use this equation. So this equation is very important for us to understand. This means that PV over T is a constant. So, and it is derived from what we have said, from Charles' law and Boyle's law, can be used to determine the general gas equation. By considering before temperature, now the volume before it was this one, then the volume was changed to this one at constant temperature. This is Boyle's law. Then the pressure, this one, was kept constant, therefore the volume and the temperature were varying according to Charles' law. Then this is the general gas equation. Now let us see the example on how we can apply this one. And want to discuss about it. This is an example that can apply general gas equation. If now you want to know the general gas equation, how is it applied, you look at the equation. If now you find all the factors that are there, that is general gas equation. Now we have a sample of oxygen gas has a volume of 0.11 meter cubic at a temperature of 12 degrees Celsius and a pressure of 8.1 times 10 raised to power 4 Pascal. While a sample of nitrogen gas has a volume of 0.18 meter cubic at a temperature of 22 degrees Celsius and a pressure of 1.03 times 10 raised to power 5 Pascal. Which gas will have the larger volume at STP? So we are having oxygen and nitrogen. Oxygen, the volume of oxygen, V1, is equal now to 0.11 meter cubic. At a temperature of 12 degrees Celsius. But we need to convert this one into Kelvin plus 273. Definitely is equal now to 583. It is 582 Kelvin. Now, the volume of 0.11 meter cubic at this temperature, that is oxygen, and a pressure of 80.1 times 10 power 5 power 4 Pascal. Now this is all about oxygen. Now we have volume of oxygen, we have temperature that was recorded, and also we have pressure that was recorded. Then the question is to determine the new volume that will be determined at STP. At STP, temperature is equal now, it will be T2. Temperature now is equal to 0 degrees Celsius at STP plus 273. Now, this T, the second temperature at STP is equal now to 273 Kelvin at STP. And at STP, pressure, the second pressure, is equal now to 1.013 times 10 power 5 Pascal. This is constant at STP. Now, we've been asked to find out the volume at STP. If now we are looking for the volume at STP, before the volume is like here, and its temperature is just here, and pressure is just here. But then at STP, the temperature is 273 Kelvin, and the pressure this one. What is missing is the volume. Therefore, from general gas equation, we have P1 V1 over T1 is equal now to P2 V2 over T2. Now P1 is 8.1 times 10 raised to power 4. And then times V1 is equal now to 0.11 over T1 is 285. Remember, P2 is 1.013 times 10 power 5 times V2 is absent over T2 is 273. Now, once you cross multiplication, and then you'll be getting this times this one. It is 8.1 times 10 power 4. It is 8.1 times 10 power 4. Then times 0.11 over, it is 285. Is equal now to pressure 1, pressure 2. 1.013 times 10 raised to power 5 times the second volume that is missing over the second temperature 273 that is at STP. Therefore, you cross multiplication. Therefore, we'll be having 285 times 1.013 times 10 power 5, that is V2, is equal now to 8.1 times 10 raised to power 4 times 0.11 0.11 times 273. Therefore, you divide here by 285 times 1.013 times 10 raised to power 5. And then both sides, it is 285 times 1.013 raised to 10 power 5. That is half. Now this cancels. Therefore, the volume will be equal now. Volume will be equal now to 0.084. This is it. We were talking about it. What is the volume? It was liter in terms of what? Meter cubic. Now this is meter cubic. Now this will be the second volume of oxygen at STP. Therefore, for this is for oxygen. Then let's for nitrogen. Nitrogen, when you look back to the question, the sample of nitrogen gas has a volume of this one. Volume of nitrogen gas was equal to 0.18318 meter cubic. At a temperature 1, that was 22 degrees Celsius. We convert into Kelvin by taking this 373. Therefore, this is equal now to 5.9. It is now to 5.9. It is 295. For this is 5, this is 9, this is 200, this is Kelvin. Therefore, that is the second, the temperature. And the pressure of 1.03 times 10 raised to power 5 Pascal. Then what will be? This volume at STP. At STP, pressure, the second pressure will be equal to 1.013 times 10 power 5 Pascal. That is constant. And temperature, that will be equal to 273 Kelvin. That is at STP because it is 0 degrees Celsius. 0 degrees Celsius is equivalent to this one. Therefore, from Boyle's law, we have P1 V1 over T1 is equal now to P2 V2 over T2. Now we substitute what we've been given. We have pressure 1. The first pressure is 1.03 times 10 raised to power 5 times the first volume is 0.18 over temperature 1 295 is equal now to the second volume. The second pressure is 1.013 times 10 power 5 times the second volume that is missing. Then over temperature 273. Now mathematically you cross multiplication. You definitely find it is 295 times 1.013 times 10 raised to power 5 is it times V2 is equal now to 1.03 times 10 raised to power 5 times 0.18 times 273. We are looking for the value of V2. Now 295 times 1.013 times 10 raised to power 5. We divided both sides. The same applies to here. 295 times 10, times 1.0313 times 10 raised to power 5 times. This is what we are looking. Now we are looking for this one. Now this comes up with this one. Therefore, mathematically, if now you do something there, you will definitely end up getting volume. The second volume is equal to 0.17. This is meter cubic. Now this is the second volume at STP. Now this is for the nitrogen. This is for nitrogen. Therefore, we've been asking which gas will have the larger volume at STP. Which gas will have the larger volume at STP? This is for nitrogen. Now the volume of nitrogen will be greater than the volume of oxygen at STP. At STP. As we have seen, 0.17 meter cubic is greater than 0.013 84 meter cubic. So that's how. So in general, if now you find the question involving three factors, pressure, volume, and temperature, and one of them is missing, you need to calculate on the second condition, you have to use this equation. Do you guys see?